In this video, we are going to be taking guided notes on how to do prime factorization. So prime factorization is a number represented as the product of only prime numbers. All right, so I want you to think of a cake. If I were to ask you, what are the ingredients of a cake? You would probably say, oh, well, there's flour and sugar and milk and eggs and oil and baking powder, and you would name all of those ingredients. That is what a cake can be broken down into. So when we say prime factorization, it's kind of the same thing. I were to ask you, what are the ingredients of a number? So what are the ingredients of 100? The number 100 can be broken down into 10 times 10, and that 10 times 10 can be broken down into 2 times 5, and then another 2 times 5, and those would be the prime ingredients of that number. Okay, so next to where you're going to put your guided notes in your math journal, if you could write the following sentences and pause if you need to catch up and write. So prime numbers are the building blocks of all numbers. So when you do the prime factorization, you want to break down each of those numbers down to their base building block, into their prime numbers. And every number can be broken down into a unique set of prime number factors. So every number is made up of a different set of ingredients. Okay, so let's look at the strategies of how we do the prime factorization. So we're going to go over two different methods. The first one, making a factor tree, and the other one, doing subsequent division. Okay, so we're going to start with, let's say the number 72. So I ask you, what are the ingredients of 72, or what is the prime factorization of 72? All right, so the first thing I'm going to do is I'm going to think of what factors do I know of 72, meaning what numbers, when I multiply them together, will equal that. Well, I know 72 can be 8 times 9. All right, now we want the prime factorization. 8 is not a prime number, so I know I can break it down further. 9 is not a prime number, so I can break that one down further as well. So 8 can be broken down into 2 times 4. Aha, well 4 is a prime number. So, or excuse me, 4 is not a prime number. 2 is a prime number. So I'm going to circle that 2. Now 4 is not prime, so I'm going to break it down further. 4 is equal to 2 times 2. 2 is prime, so I'm going to circle it. Okay, so now this branch of the tree stops here. I have broken it down as far as it can go. Now I'm going to go over to my other branch, my 9. 9 can be broken down into 3 times 3. 3 is prime, so I'm going to go ahead and circle the end of those branches to show that I'm done. Now, once I have gotten down into the base ingredients, or the prime numbers, I'm then going to take those numbers and I'm going to line them out and organize them from smallest to largest, grouping together those numbers. Now, these ones are already in their order, but they wouldn't always necessarily be in order. So this is 2 times 2 times 2 times 3 times 3. Now, I am almost done, but not quite. So what I'm going to do now is I'm going to take those numbers and I'm going to put them in exponential form. So I'm going to show them as the product of powers. So if I have 3 2's, it's 2 times 2 times 2. That is the equivalent of 2 to the third power times, and then I have 3 times 3, which is the same as 3 squared, times 3 squared. Okay, so I know the prime factorization of the number 72 is 2 to the third times 3 squared. Those are their base ingredients of that number. All right, now I'm going to use the other method. It's called subsequent division. So again, I'm going to start with my number 72. And I am going to start dividing by prime numbers, and in a way that looks like an upside down division bar. So I'm going to draw it this way, 72. So I'm going to start with some prime numbers that I know are that go into 72 equally. So I'm going to start with, let's do 2. It's a good number to start with because it's just cutting a number in half, and I know that I can do that pretty accurately and quickly. So 72 cut in half is going to be 36, and then I'm going to do another division bar below, and I'm going to divide it by 2 again. I'm going to get 18, and I can see 18 is not prime, so I'm going to keep going. I'm going to divide that 18 by 2, and I'm going to get 9. I know that 9 is not prime, so I'm going to keep going. 3 goes into 9 3 times, and I now have a list of all prime numbers so that I know I'm done. Now I'm going to take those prime numbers and I'm going to line them up. Again, this one is simple because I've already done it in order, but it may not necessarily be in order, and you kind of have to organize them. Now I have 2 times 2 times 2, which again is going to be 2 to the 3rd times, and then 3 times 3 is going to be 3 squared. Now notice how I get the same result. Whether I use the factor tree or I use subsequent division, I get the same result. Okay, so either method is going to work, and yeah, I think that's about it. And it just takes a little practice, so we'll be doing more practice in class.